Hello, this is Miss Goodwin. Today we are covering Objective 4.1, Right Triangle Trigonometry. The objective is that we can solve for missing measurements in right triangles using trigonometric ratios with the Pythagorean theorem. So we are going to start off with reviewing the Pythagorean theorem. Okay. So given a right triangle with the legs A and B, and the hypotenuse C, the lengths are related as a squared plus b squared equals c squared. So if we were to square the length of both of the legs and add them together, that is equal to the square of the hypotenuse. Now in our formula, c is always the hypotenuse. And the hypotenuse is across from the right angle as I denoted here with this arrow, and it's the longest side of our right triangle. So using this formula, we can find the lengths of a third side if we are only given two sides. Let's look at a few examples. So for this first one here, we want to find the length of the third side, and if necessary, round to the nearest tenth. So first, we're going to find our hypotenuse. So go from our right angle, go across, that is this side right here. So we are calling that C. And then A and B could be either of the other two sides. So I'm going to call our empty side A and this side B. And our formula is a squared plus b squared equals c squared. Now I'm going to plug in our known values. So we don't know what a is. That is what we are looking for. We do know b is 8. So I'm going to plug that in for b. And we know c is 10. So I'm going to plug that in for c. So now we have a squared plus 8 squared equals 10 squared. Now I'm going to square both those numbers. A squared is a squared. 8 squared is 64. And 10 squared is 100. So now we have a squared plus 64 equals 100. Now to get a squared alone, I am going to subtract 64 from both sides. So we are left with a squared equals 36. Now if we take the square root of both sides, that gets rid of the exponent of 2 on the a. And the square root of 36 is 6. So our third side is going to be equal to 6. And we are done. So that is if we are solving for a leg. Now, this next example here, we are solving for the hypotenuse. So if we go across from our right angle, I'm going to call this side C because that is our hypotenuse. I'm going to call this one A this time and this one B. And as you could do either or, like I said before. So our formula is a squared plus b squared equals c squared. Same formula. This time we do know a, that is 4. So we have 4 squared. Plus b squared, b is 3. So we have 4 squared plus 3 squared equals c squared. Now I'm going to square both of our numbers. So 4 squared is 16. 3 squared is 9 equals c squared. So now we have 16 plus 9 equals c squared. Add these two together, we get 25 equals c squared. Take the square root of both sides, we get 5 equals c. And we are done. Our hypotenuse is length 5. So that is how we use the Pythagorean theorem to solve for one of our missing sides, whether it's A, B, or C. Now we're going to look at another We're going to look at some more right triangle stuff and then go into the trig. So let's flip to the next page. And we are looking at what are the parts of the right triangle. So our first side is the hypotenuse. As we already discussed, this is the side across from the right angle, and it is the longest side of the right triangle. So if we go here, this side is our hypotenuse. Okay. I've gone ahead and recolored the right angle as green because I want to specify this other angle. So before we move on to what the adjacent and opposite sides are, I want to define what this symbol is. This symbol is theta, and it just means our reference angle, whichever angle we're using to determine what we label the other sides as. Or this could be whatever non-right angle you're given. Or that you're looking for. So our next side is the adjacent side, and I'm going to go ahead and use blue. This is the side next to the reference angle. So our angle is right here. This side that is touching that is our adjacent side. Okay. And our last side is the opposite. The opposite is the side across from the reference angle. So that is this side right here. If we go it across from that, that is our opposite. And then we can abbreviate all of these as like hype, ADJ, and opposite. I recommend highlighting these if you haven't already. Now, I see a lot of students getting hung up on which side is which. So I do want to go through a kind of a little checklist of what to do in what order, or what to find. So I want to specify, don't let the orientations of the triangles trick you. The first thing you're always going to want to look for is the reference angle. Okay? You'll either be given it as a variable, like theta or x, or you'll be given the number straight up. So it might be x, theta, some number. It's just one of the other two angles that is not the right angle. After that, I will have you look for the hypotenuse and label that. So that is always going to be across from the right angle, no matter which quarter your reference angle is. The hypotenuse will stay the same, as we can see in these two triangles right here. After you've labeled the hypotenuse, you're going to find and label the adjacent side. Now this is where things can start to get a little tricky. So as we see on this triangle on the left, our reference angle is down here in the bottom right. So this means that our bottom side is our adjacent. But on this triangle on the right, our reference angle is in the top left. So that means the side on the left is our adjacent. And I'm just going to abbreviate those. Hope you don't mind. After you've labeled your adjacent, the remaining side is going to be your opposite, as I've labeled here. So notice that no matter if you have two triangles in the same orientation, the hypotenuse is always in the same spot. But the adjacent and opposite sides switch places. So you do have to pay attention to where your reference angle is. Now, go ahead, practice with these 6 triangles, see if you can figure it out. And I'm going to go ahead and reveal the solutions in 3, 2, 1. Right here. Okay, so I've labeled all of the reference angles, all the hypotenuses, all the opposites, and all of the adjacents. Now we're going to get started on using these. So let's flip to the next page. Now we have 3 new functions we are going to learn, and these are called sine, cosines, and tangents. These trigonometric functions will relate the angle of a right triangle, specifically the reference angle, to the ratios of 2 of the sides. The 3 we will be studying are sine, cosine, and tangent, abbreviated to sine, cos, and tan. So let's get started. So we're still going to need to remember which sides are which. I'm going to start by labeling my reference angles. Now, these are functions performed on the angle itself, so sine of the angle. It is not sine times angle. So like this says sine of theta, not sine times theta. Okay. These are specific functions where you plug in your angle and you're going to get some ratio. Sine of your angle is equal to the length of the opposite side, right here, divided by the length of the hypotenuse. So sine of your angle is equal to the opposite over the hypotenuse. Cosine of your reference angle is equal to the adjacent side divided by the hypotenuse. And last but not least, tangent of our angle is equal to the length of the opposite side. Also, I miswrote that. That is not the hypotenuse up there. That is the hypotenuse. Anywho, so length or tangent of your angle is equal to the length of the opposite divided by the length of the adjacent side down here. Okay, so those are the 3 functions we are using. Now we're going to look at a couple examples of expressing these angles or these ratios. So this first example here, we want to express cosine D right here as a fraction in simplest terms. So this is our reference angle. And I've marked that in our triangle here. Now, if we go back up here, we see cosine is equal to the adjacent divided by the hypotenuse. So our adjacent side is the side next to the angle, right here. And the hypotenuse is the side across from the right angle, right here. So we could say that cosine of D, of angle D, which is angle equal to adjacent over hypotenuse, cosine of angle D is equal to 9 divided by 15. Now, we can reduce this, and Delta Math does want us to reduce this. I see 9 and 15 are both divisible by 3. So I'm going to do that. So cosine of angle angle D equals 9 divided by 3 is 3. 15 divided by 3 is 5. So cosine of angle D is 3 over 5. And now we are done. Okay. Let's look at this example over here. And it's another cosine one. So we want cosine of angle Q. Now, on this last one, we were given all 3 sides. This time we are only given 2. And you know what? That is okay. Sometimes you might have to use the Pythagorean theorem to find the third side ahead of time. Or you might not have to. In this case, we don't. So again, adjacent to our angle is this side right here. So we know cosine of Q equals the adjacent, which is 6, divided by the hypotenuse, which is 22. Now, 6 and 22 are both divisible by 2. 6 divided by 2 is 3. 22 divided by 2 is 11. So cosine of angle Q is equal to 3 over 11. And we are done. And that's all you really got to do for that bit. Or that's all you have to do to find the ratios. But now we are going to be using this information to find the value of a missing side. So let's flip to the next page. And we want to solve for x, rounding to the nearest tenth if necessary. So my reference angle is right here. This is our adjacent, this is our hypotenuse, and this is our opposite. Okay, we have the angle and the hypotenuse. We are looking for the adjacent. So adjacent and hypotenuse, those mean cosine. So again, remember, cosine of our angle is adjacent over hypotenuse. Now I'm going to plug in our values. So cosine of 43 equals adjacent, which is x, over the hypotenuse, which is 30. So now I see that we have cosine of 43 equals x divided by 30. I want to get that 30 out of the denominator, so I'm going to multiply both sides by 30. Oh my goodness. So now we have 30 times cosine of 43 equals x. And you can plug this all directly into a calculator, and that will give you about 21.9 equals x. And we are done with that. Not too bad. Let's look at this next example here. We want to solve for x, again, rounding to the nearest tenth if necessary. So this is my reference angle right here, angle U. So we have angle. This is our hypotenuse, this is our adjacent, and this is our opposite. We have our opposite. We are looking for x, which is our hypotenuse. opposite and hypotenuse mean we are going to be using sine. So let's recall sine of our angle is equal to the opposite divided by the hypotenuse. So plug in our values. Our angle is 29 degrees. So sine of 29 equals our opposite, which is 5.6. And our hypotenuse, which is x. Oh no. Now we have x in the denominator. This ain't too bad. Now, anytime we have some number or function or whatever expression, we can put it over 1 and that is still true. So sine of 29 is equal to sine of 29 over 1. Now I'm going to cross multiply. Let's bring in back our skills from unit 3. So if we cross multiply, now we have x times sine of 29 equals 5.6. So now we have x out of the denominator, but it's still not by itself. We have to get rid of that sine of 29, and we will do that with division. That cancels out sine of 29, so now we have x equals 5.6 divided by sine of 29. And then plug that into a calculator, we get x equals about 11.6. And we are done. Now let's move on to the next one. Solve for x, round to the nearest tenth if necessary, okay? So we have our reference angle, like usual. This is our adjacent, this is our hypotenuse, and this is our opposite. We have our angle and we have our opposite. We are looking for the adjacent side. Opposite and adjacent means we are using tangent. So tangent of our angle, remember that equals opposite over adjacent. So we get tangent of our angle, which is 22, equals opposite, which is 96, over our adjacent, which is x. Let's put that tangent of 22 over 1 and cross multiply once again. Okay, so tangent 22 times x equals 96. Divide both sides by tangent 22. So now we have x equals 96 over tangent 22. Plug that in a calculator, we get x equals 237.6. And we are done with that. Okay, now before I end the video, I do just want to briefly look at a calculator real quick. So this is a TI-30X This is the same one we have in the classroom. Okay, so this button right here that I am highlighting in blue, that is the second key, which is used when we want the operations above the buttons. Okay. So like if we want the square root, to square root some number, you have to press second, then your x squared key, and that will get you the square root. When you're working with a calculator, you need to use this key right here that I am highlighting in yellow to to make sure your calculator is in degrees mode. Okay. And then to use any of the trig functions we covered, you're going to use these buttons right here. Sine, cosine, and tangent. And if you want the inverses, which we'll talk about in the next video, you'll click second first to get the inverses. Okay. I'm going to go ahead and do a second video for the rest of the notes, so feel free to take a little break right now, catch up on whatever you needed, and if you have any questions, let me know. Have a good day. Bye!